Hello, and welcome to Math Lessons with Linda. Today's topic is solving exponential equations with unlike bases. I have a previous video on the same topic where the bases are like bases. You may want to look at that first before you begin this one. So remembering that exponential equations are where the variable appears in the exponent, and that's what we're solving for. So today I'm going to give you something a little bit different. Here's our first one to start off with. 5 to the x equals 125. And for this problem, you'll notice right away that our bases are different. This is like saying 125 to the first power. Before I can solve this equation, I have to make my bases look the same. Now, the trick is I can only take a bigger number and turn it into a smaller base. I can't take a smaller base and make it bigger. So I'm going to focus on this 125, and it's very useful if you know some of your squareds and cubes in order to make this process go quicker. But I know that 125 is the same thing as 5 to the third power. So I'm going to rewrite the 125 as 5 to the third, which I would then raise to the first power over here. My left side, my 5 to the x, I'm keeping that exactly the same. So now I've got like bases here. So what I can do is now I can set the exponents equal to one another. So the x is equal to 3 times 1, which is 3, and that's my solution. Very straightforward for that one. There wasn't a lot in the problem. Let's look at one that's got a little more to it. 4 to the x power is equal to 2 to the x minus 3. Definitely see these x's in my exponent, and my bases are different. I'm going to work with the larger of the two bases. So I can rewrite 4 so that it has a base of 2 if I change it to 2 squared. Remember that the 2 squared then has to be raised to this x that we still had at the beginning. Over here, there's nothing to do because I already had 2 for the base. So once my bases are the same, I can basically drop them, and I'm going to multiply the 2x here and set that equal to the x minus 3 over here. So to solve, let's subtract an x. So I get x is equal to -3. If I go back and plug these in, I would probably use my calculator and do 4 to the -3rd power, and then do 2 to the -3 minus 3 power to check my answer. If it works out, even if the number is a decimal or looks a little bit funky, as long as they're equal, then you've gotten the right solution. Let's try one more. This time, I'm going to use 4 raised to the x plus 1 power, and that equals to 1 over 64. I have a couple of things happening here. I don't have bases that are the same, but I also have this fraction. So let's take this in pieces. The first thing I'm going to do is over here, I'm going to say, okay, how can I turn 64 into something that has a base of 4? And I know that 4 to the third is the same thing as 64. So my first step is going to be turning this fraction into 1 over 4 to the third power. Now, ideally, we don't want to have this expression in our denominator. So the rule is, if I'm going to move this up to the numerator, I change the sign on the exponent when I move it from one position to the other in the fraction. So I have 4 to the x plus 1 still. Over here, I have 4 now to the -3rd. So finally, my bases are the same. So now I'm going to drop those, and I'm going to set x plus 1 equal to -3. So I'm going to get x equals -4. And again, if you substitute the negative 4 in here, negative 4 plus 1 gives me negative 3, 4 to the negative third. Remember our 4 to the negative third here, so I know that it's balanced out. Those are a few examples of how to solve exponential equations with unlike bases.